This is the Pearson Edexcel IGCSE Further Pure Maths paper 2R from June 2022. Let's just do it. It's got a position vector here and a point B here with A, B, this. The formula is A to B is minus O to A plus O to B. And if you imagine like an XY axis, an A over kind of in the top left and B in the top left down here somewhere, or this is the top right, isn't it? OA is out here, OB is out here, A to B is this length, and you go backwards and then forward. So backwards along OA, forwards along OB, back to the origin, and then back to OB again. So that's where this formula comes from. Imagining that in your head, I probably could have drawn it, but who cares? Anyway, now we've got AB as this, we've got OA as this, we can just solve for OB. By just doing stuff, we get this, that's not a problem. Find the magnitude of AB, so that's just this squared plus this squared square rooted, which is 10, and then the unit vector is just, because this length has got length 10, unit length has length 1, so you just divide this vector by 1, keep the vector as it is to make sure it's parallel still, and you just end up with this here. Question 2, so we've been told a few things here. dv by dt is 8, is the first thing that we're told here. We've got a cuboid with square base x, so the base on the bottom is x squared and height 3x means the total volume is 3x cubed. And I can differentiate that to find dv by dx to be 9x squared. And I'm being asked for the rate of increase, so dx by dt when x is 2. How do I get dx by dt? Well, I can use these two things here, right? Because dx by dt is going to be dv by dt times dx by dv, because these two things can sort of cancel, and you'll be left with dx by dt. Now, this is just 8, as I've said here. This is this upside down, so it's that. And this is just 8 over 9x squared, and at x equals 2, that's going to be 8 over 36, which is, I think, what, like 2 over 9 or something like that, and we're done. Question 3, so geometric unions goes A, then AR, then AR squared, and so on. So this is each term. The third term, therefore, is AR squared, that's 5. And the fifth term is, therefore, AR to the 4, which is 5 halves. Do this divided by this. 5 over 2 divided by 5 is a half. So we get R squared as a half, so R is 1 over root 2. It's positive, so it's not negative, that. And of course, if you know that, you can look back at this. R squared is a half, as we saw there. A times a half is 5, that means A is 10. Sum to infinity is in the formula book, it's A over 1 minus R. So therefore we have A is 10, R is 1 over root 2. You can just type that into a calculator if you're a scumbag and just immediately read off the number. Otherwise, you need to do a bit of work here, times maybe the denominator by root 2 over root 2 to get this. And then this root 2 can bounce up to there, and then you can rationalize by timesing by root 2 plus 1 over root 2 plus 1. Given this is only 2 marks, just typing that into a calculator and getting the answer is going to be the most efficient and correct way of doing this. Question number 4, if x plus 1 is a factor, that means f of minus 1 is 0. So let's put that information in. And of course, from remainder theorem, this means f of minus 2 is minus 5. So we can put both of those pieces of information in, substituting x is minus 1 into here and just having the answer of 0. And then x is minus 2 and having the answer of minus 5. When we clean everything up, we'll end up with 2 expressions, which look like this and this. If you double this one to get minus 12 equals 2p minus 2q, and then do this minus this, I think you'll end up with positive 8 equals 2p, because it will be minus 4 minus 12 is positive 8. The q's will go away, and then 4p minus 2p is 2p, and then you end up with p is 4, which you can put back into here to work out q is 10. You can put that information back into here, like this, and then you know x plus 1 is a factor, so you can factorize that out. If you want to, you can do polynomial division, or you can just spot that this must be an x squared to make an x cubed here, this must be a 7 to make this a 7 here, and then this one here, currently we have plus 7x, and we need a plus 10x, so we need another 3 of them from this expansion here. So this will be the correct thing here, and then therefore we'll have answers of x minus 1, or the answers from this one here. Now if you do b squared minus 4ac, you'll see that's less than 0. And so therefore there are no real solutions to that, and the only real root is that x equals minus 1. Question 5 then, so we get 2 marks for typing in 3 to the power this minus 2, and this, sorry, e to the power 3 times this, and this times this. You get these 3 numbers. Then you get a further 2 marks for being able to plot these pairs of coordinates and put a line through, which in PowerPoint is surprisingly difficult. Well, on a touchpad, but this is the best I could do. It's not. That was the first attempt, and I decided to keep it because why would I bother doing anything else? Then by drawing a suitable line, we need to solve this. Now we need to relate this back to the thing that we've already drawn, which is this here. So let's take away 2 from both sides, and then let's do e to the power of both sides, and then this becomes the thing that we've drawn already. So therefore, all we need to do to solve this equation is find the intersections of this graph and this graph. This is just y equals 3 minus x. It's got a y-intercept of 3. And a gradient of minus 1, so it goes down 1 across 1, so it looks like this. The x-coordinate of intercept looks like it's about 0.9 to one decimal place, so therefore I'll say the solution is 0.9. Question 6, if I just call all of these side lengths 2, because I can, that means that this length down here is going to be Pythagoras. This length, of course, is 1, so I can just do 2 squared minus 1 squared, which is root 3, and that length is root 3. This length down here, I don't actually need, but this length across is also 1, because it's a half of this length. And now this angle here is the angle between VCD and the base ABCD, which is what I'm being asked for. So now I just do cos inverse of 1 over root 3 in a calculator, and I'll get the answer nice and easily. Question 7, solve the equation this. So if I times this by 3 and then take away 15, I'll get the range of things that I'm looking for. Do cos inverse of root 3 over 2 and you get 30. But then, okay, so cos is the one where you have to do 360 minus that, so that's going to be 330, and then just add 360 to both of these, but that gets you out of this range, so that's no point in doing that. Cos is also symmetrical, both sides of the y-axis, so but also you have answers minus 30 and minus 330, but again, those are outside the range. So at this point, we just add 15. In fact, sorry, if you add 360 to this one, you do get 390. Apologies, yeah, of course. So this is the first solution. Add 360 to this one, and you're out of the range. So okay, those are the 3 solutions. Add 15 to all of them, and then divide all of them by 3, and you'll get your solutions there. For this one, I wrote tan y as sine y over cos y, and then I divided all 3 terms by sine y. Now I'm allowed to do that as long as sine y isn't 0. So now I'm just going to check if sine y could be when sine y is 0, which it happens, of course, when y is 180 or minus 180 or 0. 0 and minus 180 are allowed, 180 isn't, so that would be the 2 solutions there. So okay, I'm allowed to go from here to here as long as I note that these 2 things are solutions, because they're making the whole thing 0 equals 0. So those are the first 2 solutions, and now for this bit here, I'm just going to times everything by cos, and then take away 3, divide by 4, and then do cos inverse of minus 3 over 4 to get this answer. Again, 360 minus that I could use, but that's going to be too big. But cos is symmetrical around the y-axis, so I can also use minus 138.6, and those would be the 4 solutions just there to this second one here. The third one here, replace sine squared with 1 minus cos squared, expand out and rearrange to make it quadratic. You can replace cos theta with like y if you want to, or you can just factorize straight away. It looks like this. So therefore cos theta is minus 1, or cos theta is 2/3. Once more, do cos inverse of both these. Now cos theta is minus 1 is just minus 180. I believe, because you're for some reason not allowed to use positive 180. But minus 180 is fine, and then cos inverse of 2/3 is this. Do 360 minus that, but that's going to be too big, so now just use the minus 48.2 because cos is symmetrical and has positive and minus values for each of any values that you find. And I think that's going to be all of the answers to question 7. Question 8, so of course to find this intersection here, we do this equals this. We can tidy it up a bit, but to solve this, we just need to times everything by e to the power 3x. That creates here 10 e to the 3x. The e to the 3x plus e to the minus 3x, because the indices add, right? That just makes e to the 0, which is 1. And then e to the 3x times e to the 3x, I can just write as e to the 3x squared, and then move these 2 terms over, and you get what they wanted you to get. This is another quadratic, so you could replace this thing with y and make y squared minus 10y plus 9, which factorizes, or you can just factorize straight away and not bother with the substitution. So of course here, either e to the 3x equals 9 or e to the 3x equals 1. Here, this means 3x is 0, which means x is 0, which is this intersection here, which I'm not interested in. And here, take log of both sides and divide by 3. And you end up with this here, which is what they wanted us to get at this point here. Find the region here. So now we're going to do the integral of this curve between 0 and 1/3 log 9, and then take away the integral of this curve between the same 2 values. If you're integrating between the same 2 things here, you can just bring the equations together. So 9 minus minus 1 is 10, and this minus this doesn't go together, so we just leave it like that. Now we're going to do some integration. So this integrates to 10x. This, you divide by minus 3 to get a plus 3, and then keep this thing the same. Divide by minus 3 to get a minus 1/3. And now plug in all of these values. This is kind of cool. When you plug in this to here, you just get 10/3 of this. When you put it into here, the 3 cancels with the 1/3 to leave you with this, and likewise here to leave you with that. Now this minus can go, by following a log law, this minus can go over here and make this into a 9 to the power minus 1, which is 1/9. And now this e and this log can cancel for both of these. For the zeros, of course, this makes 0, and then e to the power 0 is 1, so you just get 3 minus 1/3. Now the e's cancel with the logs, and then 1/9 times 3 is 1/3, and 9 times 1/3 is 3. and we end up with this, which simplifies eventually to this, which will be our answer in exact form, I guess, is one way of writing it. Write this in this form. So we're going to factorize out 3 from the bottom here, but we are going to do it very carefully because you can't take it straight out. You've still got this power 3 here, so that distributes to both of these two things here to create this. And then 3 cubed is 27. 3 over 27 is a ninth, so we end up with this here. And so the answer is a ninth into a third here, and we'll have this here. Okay, now we can express this in powers using this formula here. So every time we see an n, that will be minus 3, and every time we see an x, we'll use minus a third x. And we'll just make the minus a ninth go on the outside of big brackets here. So this is just me following this exact formula that's in the formula book with exactly what I said I would use, and then I'm just going to type all of each individual thing into a calculator to get these answers here. Now I need to use a suitable value of x to return an approximation for this. So I want this to be this thing here, because this is the approximating thing that I'm going to use. Of course, this is equal to this, which is equal all the way back to this. So I think I can just set this thing here equal to this and solve for x, and that will be the x value I need to put into this, because this is equivalent to this, which is equivalent to this. So just to solve this for x, I think I just flip them over. This can go down to an 8 if you get rid of this. Oh, sorry about that. Which means I can now cube root to make a 5 over 2. I can add x and take away 5 over 2 from both sides to get x to the half, which is good. So I can now just use a half in this expression here, because those two things are equivalent. I jumped to here halfway, but it doesn't matter. I can just say those two things are equivalent. And this is equal to 25 over 125, like I said here, if x is a half. So if x is a half, this turns into a 24 over 125, and this turns into whatever it does when x is a half, which is roughly this. And so therefore those two things are the same, roughly speaking, to this decimal place here. Find the percentage error, so find the difference between these two things, and then divide by the true value, which is of course the fraction, and then times by 100, and you'll get this percentage error here apparently. Question number 10, so equation of the asymptotes. So the asymptote, the x-asymptote, is when you're dividing by 0, which is when x is 3 over 2. It actually tells you right there. And then the y-asymptote is 7 over 2. Why is that? Well, if you use y as 7 over 2 and then cross-multiply, 2x times 7 over 2 is 7x, and then you'll end up with some number afterwards. But the 7x's will cancel, and you'll end up with some number equals some different number, which obviously can't happen, and so that's therefore is an asymptote. Coordinates of intersection with coordinate axes. So when x is 0, you get y as minus 2 over minus 3, which is just 2 over 3. And when y is 0, this doesn't matter. You just get 7x minus 2 is 0, which means x is 2/7. And those are the coordinates. Use calculus, show c is negative. So we need to differentiate this, which we can use quotient rule for. So square this on the bottom. The derivative of this is 7, times it by this. That will be the first term. And then the derivative of this is 2, times it by that. That will be the second term with a minus in between. If you simplify this, you get 14x minus 14x. That all goes away. And minus 21 plus 4 is minus 17, and you get this. But the denominator of this is always positive, and the numerator is always negative. Negative divided by positive is negative. So every point on this curve, c is negative, except for when x is 3 over 2, because that means you're dividing by 0, but you're already not allowed to do that. So, okay, good. Sketch this curve then. So we have asymptotes at x equals 3 over 2, y is 7 over 2. We have these two coordinates on the axis, which are here and here. And these curves always look like two C-shapes in opposite quadrants. We know it's in this quadrant because it goes through those two. So therefore, it's up here as well, and it looks a bit like this. Finally then, to finish up this question, straight line L is normal to C at the point A. So we've got a straight line, maybe this is point A, and it's normal to the curve here. And then it also touches the curve somewhere over here. You know the gradient of this is 17, apparently. So, okay, we've got a lot to do here. That means the gradient of the curve at this same point is minus 1 over 17, because they're normal to each other. So let's set minus 1 over 17 equal to this to solve for x. Cross multiply and get rid of the minuses maybe. You can cancel the squares down to a plus minus, but of course x is positive apparently. So we're actually going to use positive 17, add 3 and divide by 2 and you get x is 10. If you have x is 10, you can shove that into here to find 68 over 17, which I think is 5. Sorry, it's 4. So this coordinate here is 10, 4. Now, that's helpful because it allows us to find the equation of the line, because we have the gradient is 17, and we now know it goes through this point here. So I can just put an x is 10 and y is 4 into there, and you get c is minus 166. So that's the equation of this line. And finally, to find the solution over here, we're going to find when this line intersects this curve. So just set the two things equal to each other. You know one solution is when x is, what was it for? Sorry, when x is 10. So that might be helpful later. But for now, just cross multiply, expand all this out, gather everything up, and you can just use quadratic formula here, right? You know x is 10 was a solution. Also allows you to factorize this. You can just say one bracket must be x minus 10. So the other one, therefore, must be 34x minus 50, which gives you solution 50 over 34, which is 25 over 17. And then just shove this 25 over 17 into here. The 17's cancel. 25 minus that is minus 144, and that's the exact coordinate of b. Good. Question 11 then is the last question. The volume is pi r squared h, and the surface area is 2 pi r squared, because there's two of these, and then 2 pi r is the circumference times by h to get the curved surface area, and that's apparently equal to 600. We can rearrange this one for h by doing minus 2 pi r squared divided by 2 pi r to get h, and then shove that h into here, and we get volume as this. When you expand this out, this pi cancels with that, this r cancels a bit with this, you get 600 over 2 is 300 times an r, which is the first term. And then here, this pi cancels, this r cancels a little bit, with 2 more r's makes r cubed. The 2's cancel, and so you just end up with minus pi r cubed as your volume. When this is a maximum, so v dashed, the derivative of v is 300 minus 3 pi r squared. That needs to be equal to 0 to find a maximum or a minimum. Bring this over to the other side, divide by 3, and divide by pi, and square roots. R has to be positive because it's a length, so therefore r is this. We need to demonstrate that it's a maximum, so let's do v double dashed, which is just this goes away, so you end up with minus 6 pi r. But of course, for any positive r, which this has to be because it's a length, this is definitely negative. So this should be a less than 0 sign. And because it's less than 0, that means it's a maximum. So that should be a less than 0. It's less than 0 and r is positive, clearly, because you're just multiplying positive numbers together. That should be a less than sign, and therefore it's maximum for any value of r, including the one that we found before. So if r is this, that's the maximum we can get the volume to be. So let's put this r into here to find our v maximum. I've put it into this one, actually, which is obviously equivalent, but whatever. You get v is this, roughly. I've held that number in a calculator, because if I know that's the maximum value of v, if this is being melted down and made into a sphere of maximum volume, I'm just going to set this volume here equal to 4/3 pi r cubed, which I think is in the formula book. And yeah, just times by 3, divide by 4, divide by pi, and cube root, and you'll eventually find p, which is what they've called the radius, is this here, and that's the entire bit. But thanks for watching. I'll see you next time.